In my second proof by induction example, I'm going to attempt to prove the result. The summation from r equals 1 to n of 2 plus 3r is equal to n over 2 times 3n plus 7. Now, the detailed explanation was given in the first example, so I'm going to go through this example a little bit more quickly. The first step that we did was to give the proposition a name. So we're going to do that again. It's P of R, and R takes values from 1 up to n. Basis step. In the basis step, we attempt to show that the very first case is true. The first case is r equals 1. So r will take the value 1 and n will take the value 1 for the basis step. So on the left hand side, anywhere we see an r, we replace it with a 1. So that's 2 plus 3 times 1 equals, and on the right hand side, anywhere we see an n, it will also take the value 1. So 1 over 2 times 3 times 1 plus 7. That works down to a half of 3 plus 7 is 10, and that is equal to 5. On the left hand side, we get 2 plus 3 times 1 is 2 plus 3, which is 5, and therefore the basis step checks off. Left hand side is equal to right hand side, so on to the induction step. Again, we begin by assuming the proposition to be true. We assume P of R is true. That is, the summation from r equals 1 to n of 2 plus 3r is equal to n over 2 times 3n plus 7. And the inductive step basically boils down to us proving that if the nth case is true, then the n plus 1th case must be true. So if P of R equals n is true, then P of R equals n plus 1 must be true. Once we have shown this, we will have succeeded in our induction step, and therefore the proof would be complete. So we must show that since the summation of r equals 1 to n of 2 plus 3r is equal to n over 2 times 3n plus 7, then the summation from r equals 1 to n plus 1 of 2 plus 3r is equal to n plus 1 over 2. So anywhere on the right hand side we see n, we replace it with n plus 1. So 3n becomes 3 into n plus 1, plus 7. That is equal to n plus 1 over 2 into 3n plus 3 plus 7, which is equal to n plus 1 over 2 into 3n plus 10, which is equal to, we're going to put everything over 2. So n plus 1 by 3n plus 10 will give us 3n squared plus 3n plus 10n. So that's plus 13n plus 10. So we need to show that this summation here of r equals 1 up to n plus 1 of 2 plus 3r is equal to 3n squared plus 13n plus 10 divided by 2. So alright, so we will continue from this point. Summation from r equals 1 to n plus 1 of 2 plus 3r is equal to the summation from r equals 1 to n of 2 plus 3r, and then we will add on. So we have summed the first n terms, and now we must add on to that the n plus 1 term. So where we see 2 plus 3r, we're going to replace r with n plus 1. So 2 plus 3 into n plus 1. And we will recall by our assumption, so I'll just remind you, here was our assumption. We assume that p of r equals to n is true. So that is the summation from r equals 1 to n of 2 plus 3r. That is equal to n on 2 times 3n plus 7. So this is equal to n on 2 times 3n plus 7. And then we're going to add on to that the n plus 1 term, which is, I'm going to expand this, 2 plus 3n plus 3. Now I must show, remember what I'm trying to show, that this is 3n squared plus 13n plus 10 over 2. And the right hand side now, so we're trying to get what's on the left hand side there. Good, so when I expand here, I will get 3n squared plus 7n over 2 plus 3n plus 5. Now I'm going to put that right side over 2. So everything is going to be over a common denominator of 2. So this is 3n squared plus 7n plus, so 3n is the same as 6n over 2, and 5 is the same as 10 over 2. And there you can see, when I combine the two middle terms, 7n plus 6n, I will get my 13n. So this is equal to 3n squared plus 13n plus 10 over 2. So I was able to show that the summation from r equals 1 to n plus 1 of 2 plus 3r is equal to 3n squared plus 13n plus 10 over 2, which is what we would get when we sum the first n plus 1 terms. That's what I would get when I substitute n plus 1 in the original proposition. So the inductive step also checks out, and therefore, since I was able to show that when Pn is true, then Pn plus 1 is also true, I have shown that every subsequent case must be true. So I started by proving the basis step. When r is equal to 1, the proposition was true. And my induction step now implies that if r equals 1 is true, then the case where r equals 2 must be true. And when r equals 2 is true, this implies that the case where r equals 3 must be true, and so on. So this proposition has been proven.